Now we are going to see a problem on boiler efficiency. Let us see the problem. A boiler generates 6200 kg of steam per hour at 9 bar and 0.93 dry from feed water at 38 degrees centigrade when using 825 kg of coal per hour having a calorific value of 31,000 kilojoules per kg. Determine the efficiency. Now here if you see the given data, mass of the steam generated per hour is given. Let us take it as ms as 6200 kg per hour and it is generated at the pressure of 9 bar. So this small p is 9 bar and it is the dryness fraction is given and it exceeds 0.93. So and let us take this as at the second condition, means steam forming is taken as second condition and we can take it as P2 or it is X2 like that. And the water condition, let us take it as a one condition. So the feed water is supplied at the 38 degrees centigrade, means let us take temperature of feed water is 38 degrees centigrade and mass of the coal per hour is given, means so here the coal is the fuel to form the steam. So let us take mass of the coal as a mass of the fuel is given as 825 kg per hour. So it is mf is equals to 825 kg per hour and the calorific value is given 31,000. Let us take cv as calorific value 31,000 kilojoules per hour. And if you go to the next slide, so here what we have to find here, it means efficiency we have to find out for this boiler. So efficiency means here the thermal efficiency we want to find out. So we know from the basic uh, concept of efficiency, it is the ratio between the output to the input, means how much output you are getting and how much input you are giving. So it is a ratio between output to input. So here when it comes to the boiler, so boiler efficiency means here we have to find out boiler thermal efficiency. So the output is how much amount of the heat coming out and how much amount of heat you have supplied. So how amount of heat coming out means heat coming out from the steam or heat utilized to form the steam. So this will become output here and here heat input means here heat supplied and heat supplied will be the heat energy supplied from the fuel. So this will become input here and if you find out these two and if you find out the ratio, you will get the boiler thermal efficiency. And how to find, just see. So see here the heat of the steam or heat utilized to form the steam is given by this formula ms into H2 minus HF1. So here this steam we are taking it as a second condition and this feed water is supplied as the first condition we are taking and it is a boiler. So when you supply you will get steam. So this is the heat of the steam is total heat of the steam is ms into H2 minus HF1. So this will become output here because this is coming out. So this is output and heat from the fuel, so which is supplied to heat the water, so that will become input here. So the total heat will be total mass of the fuel into calorific value will get the total input heat here. So and here this when you write the relation or when you write this formula, so boiler efficiency or boiler thermal efficiency will become ms into H2 minus HF1 by mf into Cv. So here we have to find out the H2 and HF1 values. Here HF1 or H1 is the enthalpy of feed water at the first condition. So and Cv value is given, ms and mf value are given in the question itself. So let us find out H2 and HF1 from the steam tables. So here before that we have to write a formula for enthalpy of the steam at the second condition, that is nothing but H2. So here because it is given the steam is forming the dryness fraction of the steam at the condition is 0.93, which is given in the question. If you see friends, it is given the steam is forming at 9 bar and 0.93 dryness fraction means, so this is x2 here it is. So from this we can say that the steam is in the wet condition. So from that we can write formula of wet steam as Hf plus x into Hfg, and because we are taking the second condition, so it is H2 is enthalpy of steam at the second condition is given by Hf2 plus x2 into Hfg2, means we have to take this Hf and Hfg values at the 9 bar, that is the meaning here. So from the steam tables at the 9 bar, let us see these values of the enthalpy of the steam. So at the 9 bar, if you see friends, so this is an saturated water and steam tables, and this is the pressure based tables. So if you see, first column is pressure, and we require at 9 bar what is the HF value and HFG value. So friends, if you see here at 9 bar, so HF value will become here, if you see 9 bar, so this is the 742.6 is the HF value, and we require HFG value. So that is here, HFG is 20 29.5, 2029.5. So these are the values of steam, enthalpies of steam at the 9 bar. So HF value is at the 9 bar, HF value is 742.6 and HFG value is 2029.5. So let us substitute these values in the formula. So HF value is 742.6 and HFG value is 2029.5. These are from the data book, and when you substitute in this formula, so you will get enthalpy of the steam is 2630.035 kilojoules per kg, and we got H2, and we require H1 or HF1, which is the enthalpy of the feed water at the temperature of 38 degrees centigrade. So let us find out this enthalpy from the steam table. So this we have to find from the temperature based tables, because temperature of the water at the inlet is given. So you have to find out at the temperature based tables. At the 38 degrees centigrade, the HF value is 159.1. Let us see friends, here 38 degrees centigrade. So if you see against this HF value is 159.1. So this is the at the first condition, the water is at the purely at the liquid state only. So here we just directly take this HF value as the enthalpy of the water at the first condition. So at 38 degrees centigrade, 159.1 will become the enthalpy of the water at the first condition. So that it will become HF1. So when you substitute those values here, MS mass of the steam is given 6200 kg per hour given, and H2 value we have calculated here 2630.035, and HF1 value we have find out from the steam tables 159.1, and mass of the fuel is given, that is coal, per hour is given 825 kg per hour is given, and calorific value is given 31,000 kilojoules per kg, and when you simplify, you are getting 0.599, means 59.9 something percent, and approximately it is the 60%. So this is the efficiency of the boiler from this given data. Yes, so friends, for more videos, please subscribe and activate bell symbol. Like it, share it, and don't forget to subscribe. Thank you.